Welcome, my friends! Consider this problem. Luke drove 420 miles using 18 gallons of gas. If he continues to use gas at this rate, how many gallons of gas will he need to drive 357 miles? The best way to think of this type of problem is using a ratio, sometimes called a proportion. We are given both miles and gallons of gas, which are dependent on each other, so we can use the ratio of miles per gallon, or miles divided by gallons. After 420 miles of driving, 18 gallons of gas have been used, so we could think of the miles per gallon as 420 divided by 18. We want to know if 357 miles were driven, how many gallons of gas would be used. So the second piece of information is just another ratio of miles per gallon, but we are missing the gallons part. That means we must have 357 miles divided by G gallons. It makes sense to assume that whatever the rate of miles per gallon that Luke got when driving 420 miles, he will also get the same rate when he drives 357 miles, so we can set the two rates equal to each other. Now we have an equation which we can solve for G, which I am going to rewrite without the units. I just want to note that if you had your fractions flipped, this would still work. So if you had gallons per mile, like this, you could still solve and get the right answer. Okay, so now we have two fractions set equal to each other, so we could cross multiply to solve for G. We have 420G is equal to 357 times 18, which is equal to 6,426. Dividing both sides by 420, we get the answer, which is 15.3. Luke needs about 15.3 gallons of gas in order to drive 357 miles. Let's try another one. In a vote for mayor, the ratio of yes to no votes was 6-5. If there were 2,955 total no votes, how many total votes were there? Now be very careful here. Our two pieces of information are not equivalent. The first sentence tells us the ratio of yes to no's. The second sentence tells us the no's, but it doesn't ask us for the yeses. It actually asks us for the total number of votes. There are two main ratios we could set up with this problem, and only one of them is going to help us. We could set up a ratio of yes votes to no votes, or we could set up a ratio of no votes to total votes. If we read the problem, we are trying to find the total number of votes, which means ratio 2 is probably correct, as it includes the total number of votes. Ratio option number 1 probably won't work, as it does not contain the total number of votes. Okay, so let's set up the problem using ratio option number 2. We are told that the ratio of yes to no votes is 6-5. Another way to think about that is that for every 11 votes, 6 are yes and 5 are no, as 6 plus 5 is equal to 11. That means a ratio of no's to total votes could be expressed as 5 no's per every 11 votes. Now this ratio is equivalent to the information in the second sentence. There are 2,955 no's, which is some ratio of the total number of votes, T. These two ratios are equivalent, as the ratio of 5 to 11 should also apply to the total number of votes. Let's rewrite the problem without the units. Now we can cross multiply. We have 11 times 2,955 and T times 5. 11 times 2,955 is 32,505, which is where that number came from. Now we can divide 32,505 by 5 to solve for T. We get T is equal to 6,501. That means there must have been 6,501 total votes, which is our final answer. How about this one? One hose takes 70 minutes to fill a swimming pool. A second, bigger hose can fill the pool in 30 minutes. If both hoses run together, how long will it take to fill the pool? Okay, the way to tackle a problem like this is to think about how much each hose fills the pool in 1 minute. Hose number 1 fills the whole pool in 70 minutes. That means it fills 1/70th of the pool each minute. Hose number 2 fills the whole pool in 30 minutes. That means it fills 1/30th of the pool per minute. These two hoses are working together at the same time, which can be expressed as the sum of the two rates. Together, we don't know how long it will take to fill the pool. So we say in 1 minute, the combined two hoses can fill 1/x of the pool, where x is the number of minutes it would take to fill the pool with both hoses together. Now we have the equation 1/70 plus 1/30 is equal to 1/x. The left-hand side of the equation represents the two hoses working together, which is why we have added their rates. The right-hand side represents the combined rate of the two hoses. Let's multiply by the least common denominator, which is 210x. 210 divided by 70 is 3, so we have 3x on the first term. 210 divided by 30 is 7, so we have 7x from the second term. On the right-hand side, we have the x's, which will just cancel, and then we are left with just 210. That leaves us with 10x is equal to 210 when we add the x's. Dividing each side by 10, we have x is equal to 21. If the hoses are working together, it will take them about 21 minutes to fill the pool. Alright, let's try one final problem. Two hoses together take 35 minutes to fill a swimming pool. The larger of the two hoses takes 60 minutes to fill the swimming pool when working alone. How long will it take the smaller hose to fill the pool on its own? Okay, this problem is very similar to the last one, but it's slightly different. Last time we had 1 over the hose 1 minutes plus 1 over hose 2 minutes is equal to 1 over the combined minutes. Use the same idea and just fill in the numbers where we have the information. It takes 35 minutes for the hoses to fill the pool working together, so the combined hoses amount must be 35, so we can fill that into the formula. It takes 60 minutes for the larger hose to fill the pool, so we can let that be the rate for hose 1, or hose 2, it doesn't really matter. We need to add that to the rate of the second hose, which we don't know yet, so we can let that just be 1/x. Altogether, we have 1/60 plus 1/x is equal to 1/35. Now we need the LCD of 60 and 35. This is a bit tricky, so let's write out the multiples of both 60 and 35. We don't get a common multiple until we reach 420, so that means that 420x must be our LCD. Multiplying everything by 420x, we have 420x over 60, which simplifies to 7x, plus just 420, since the x's cancel on the second term, which is equal to 12x, as 420 divided by 35 is equal to 12. Subtracting 7 from both sides, we get 420 is equal to 5x. Dividing each side by 5, we have 420 divided by 5, which is equal to 84. That means it must take the smaller hose 84 minutes to fill the swimming pool on its own. To me, that kind of sounds like a long time. Probably either a really big pool or maybe just a low-flow hose. Who knows? Anyways, that completes our video relating to word problems for proportions and rational expressions.